Okay, so today we're going to have a look at subtopic 3.2, and we're going to have a look at a thing called one-to-one functions. So we'll start off with a couple of definitions. So what is a one-to-one function? A one-to-one function is any function where for each x there is only one value of y, and for each y there is only one value of x. Equivalently, a function is one-to-one if f of a equals f of b only when a and b are the same. Okay, so what does that mean? We'll have a bit of an exploration of this, but if we go back to that previous page, you can see for this linear function, if I have an x, so I'm in the negatives over here, I've got an x, it's got a y and it's down here. Now that y never comes up again for any x, okay? And if I go along any y, it's got an x value, that x value doesn't come up for any y. So that's a one-to-one function. However, for this quadratic, if I go over to my negatives, I come up to the function, I've got a positive y value here. Now if I go across, I've got another positive y value here. So that isn't one-to-one. Okay, we'll have a bit of an explore on a few more of those, but yeah, that's just a quick definition of that. So the second part was if f of a equals f of b, it only happens when a and b are the same. So what that means is if I've got my function and I put a number in there, so like I put a number -2 in there, it comes down here, I get out -3. Okay, I can only get out -3 again if I put in the same thing. Okay, however, on this y value, I get this positive number out here. If I put in some negative, I can get the same value if I put in some positive value. So that's not one-to-one either. Okay, so how do we test that? So a one-to-one function satisfies both the vertical and horizontal line tests. So this is a bit of a revision, the first one. The vertical line test determines whether a relation is a function. So these are all going to be relations we're talking about, but the vertical line makes it a function. Now the horizontal line test can be used to provide evidence that that function that we proved with the vertical line test is a one-to-one function. Okay, so we prove it's a function first, then we can prove it's a one-to-one function. And if both of those things hold, yep, we've got ourselves a one-to-one. You might be going, hang on, wait a minute. I'm forgetting what a vertical line test is and what a relation is and a function. Okay, and what is this horizontal line test you're talking about? So the first thing we're going to do is we're going to go through and we're going to have a look at these vertical line tests to see whether our relation is a function or not. Okay, so what I've done is I've grabbed a whole bunch of different relations and let's have a look at them individually. Okay, so we've got ourselves a relation. It's a circle here, it's on a set of axes. We are going to use, we remember which one it is. We're going to use our first one, which is our, oops, not that one, our vertical line test to determine whether it's a function. So what that means is if we grab our pen, if we draw a vertical line anywhere, it should only touch the graph once. Now that line's a little bit skewed, but just imagine it's straight vertical. You can see that it's hitting the graph here and also here. Okay, so that's going to fail the test, and that means this relation is not, so equals not a function. Okay, once it's failed that vertical test, we don't have to go on. All right, let's have a look at another one. So what we've got here is some kind of, what is it, quartic. So we're going to use the vertical line test, and we can see that no matter where we pass it through, that's only going to hit once. It's getting a bit squishy here, only once, only once. Okay, so vertical line test, that means our relation is a function, okay, because of the vertical line test. Now if we go to the horizontal line test, we can see straight away that's not good. We're hitting here, here, and here. So we're hitting 3 times. If you hit twice, it's not a one-to-one. So this is not 1-to-1. All right, so we've got ourselves a function, but not a one-to-one function. All right, we've got ourselves a linear one here. No matter what we do, if we put a vertical line through there, it's never going to hit more than once. So that means our relation, actually use my shortened version, is equal to a function. Now if I go horizontal as well, same deal, it's never going to hit more than once. So that means my function is 1 to 1. All right. So yeah, we've got one more example, I think. So again, we're going to start with a vertical line test, and we can see a problem straight away. Bang, we're going to hit twice. So therefore, our relation is not a function. Okay. And you can see these aren't very common. We don't really deal with things like this anymore, but that's the same thing there. If we ever hit twice on a vertical, it is a relation, but not a function. Okay, so what is the point of that? Basically, it's all to get down to this. So if a function is 1 to 1, so we had a couple in those last examples, then it will have an inverse function. All right, and that's important, and that's what we care about. And the way we denote an inverse function is with our f of function, that inverse 1, power of -1, and x. Okay, so that's our inverse function. And these are really important. All right, so you can find from a function its inverse if it exists. So I've picked one that we know exists. It's a linear form. So we can work out what its inverse is using a couple of techniques. I'm going to use the variable exchange way. So if I write this out, this is our function here. What I'm going to do is I'm just going to write it out with my y instead of my f of x, just because it's a little bit easier. So y equals 2x plus 3. Okay. Now to work out our inverse, of x, what we do is we change the x and the y. So I'm going to write that as x equals 2y plus 3, and we rearrange to solve for that. So therefore my x, if I take that 3 to the other side, x minus 3 equals 2y. I'm going to divide that by 2. I'm going to get y equals, so divide both sides by 2. All right. So therefore I could write this function as x minus 3 over 2. Okay, and that's equal to my inverse function. So that's what we do. We swap the x and the y's, and we just rearrange. So another little definition here. So any function which has an inverse and whose graph is symmetrical about the line y equals x, we'll have a look at what that means in a minute, is a self-inverse function. Okay, so these are a couple of examples. F of x equals x. So if I wrote that out as y equals x, all right, if I swap those, I get x equals y, which is the same as y equals x. Okay, now this is called the identity function. That's not super important, but it might be handy to know. Yeah, and the other one is this one. So f of x equals 1 over x. So if I write that as y equals 1 over x, if I switch my x and my y, I get x equals 1 over y. Now if I times both sides by y, I get xy equals 1. Now if I divide both sides by x, I get these cancel, I get y equals 1 over x, and you can see we have the same as what we started with. Okay, so that's just a couple of examples. Now, I said any function which has an inverse and whose graph is symmetrical about the line y equals x is a self-inverse function. So let's have a look at that. So if I draw my line y equals x, that's this line here, you can see what these inverses look like. All right, so this is a bit of an example. There's another one here, and these are both inverse because they do the same thing on either side. All right, so going to have a look at an example next, but I might stop here and yeah, we'll watch the next video. Thanks.